Okay, so here's example 3 in thrown objects that are in free fall. Remember, any object under the influence of gravity is in free fall, whether it's simply dropped or whether it's thrown. So this isn't really, well, it's not technically thrown, but it's hit upwards, all right? Somebody hits a volleyball and it's given an upward velocity right here. Now remember the last one, how we had that weird scenario where the guy was laying on the ground. Here we have somebody, a normal person. They have their hands out like that, and they're hitting the volleyball off the, well, where they're hitting it is some distance off the ground, all right? What distance is that? Well, it's 2 meters from here to here, all right? That's 2 meters. It's about a little over 6 feet, all right? That's reasonable for somebody to be hitting a volleyball, okay? And it goes straight up in the air with a velocity of 6. You might say an initial velocity. Let's undo that. Initial velocity equals 6 meters per second. All right? So it goes up. Now I'm going to arc this over a little bit just because I don't want to draw right back down on what I just drew right here. The idea is that this comes straight back down. It really wouldn't matter, but I don't want you to get too confused that this is some sort of projectile quite just yet. But I'm going to arc it just like that, all right? And then it comes back down and it hits the floor, all right? Because the question is really asking, how long will it be in the air before it hits the ground, okay? So first of all, we need to set a coordinate system. That is, where is our 0 level? Well, I think it's logical to make 0 ground level. That's not a very good 0 right there. And of course, I can't erase that yet. Oh well. And so our initial position, that is where the ball started, y initial, that is, oh, that's our 2 meters. It's right there. Okay, so it's starting at 2 meters off the ground here, starting here, going up, coming to a stop, and coming back down. You might think, all right, well, we need to solve for it going up, and then, oops, don't want to do that, sorry. Then we need to solve for it kind of coming back down and finding that time. Actually, you don't. You can do it all in one big step. And this is how we do it. All right, so our initial position, our y initial, we're going to say is 2 meters off the ground. What's our y final position? Our final position is at 0 meters. It's on the ground. All right, that's because we've said that the ground is going to be 0 right there. Let's write what else we know. We know our initial velocity is going to be, what was it, 6 meters per second? Okay, upwards, straight upwards. And we know the acceleration, that should be stuck in your heads by now. That's negative 9.81 meters per second squared. All right, so what do we need to solve for? We need to solve for the time, right? How much time does that take for the ball to go up and then come back down? Well, this is going to be another one of our equation 4s, all right, where we have displacement y equals initial velocity times time plus 1/2 acceleration times time squared. And this is going to be a really handy one. So you may think it's a pain to be getting out your quad form, but it really is a handy equation to use in a lot of different scenarios. So let's turn that around and just put that in standard form. All right, standard quadratic form. So I'm going to say 1/2 acceleration times time squared plus initial velocity times time minus our change in y equals 0. In fact, while we're at it, why don't we just delta y right here? What is our change in y? Well, it starts at 2 and it goes up and then it ends at 0. So that's really 0 minus 2, or rather, it displaces negative 2 meters. So that's going to be our delta y right there. So we have our quadratic equation in standard form. There's our a, there's our b, and there is our c. All right, so our a is going to be 1/2 times negative 9.81. Remember that from the previous problem, that was negative 4.905, right? Remember that? 1/2 of negative 9.81. Our initial velocity, we know that. That's just 6 meters per second. That's going to be our B right there. I'll put green brackets around that. And then our C is going to be, we're careful here, so negative delta y. Well, if delta y is negative 2 meters, then negative is just 2. Our C is going to be 2 or 2 meters right there. So that's all we do. We just plug that right into our quadratic, and we'll see what we get for our time. In fact, we'll probably get a couple different times right here, but that's all right. Our A is negative 4.905. Our B is going to be 6, and our C is going to be 2. What do we get? We get a negative time, which we know can't be possible, so the only one that has to be possible is the positive time, and I get 1.5 seconds. And there we are. That's our time for it to go up, come to a stop, and hit the ground. So we didn't have to break it into 2 parts, up and down. We could do it all in one, just by using the equations that we have. Now the second part right here, find the ball's maximum height above the floor, that just deals with the first part. Okay? It's really saying, okay, well, it goes up here and stops, and then starts to come back down. We know the initial position, that's 2 meters. We're really asking for a maximum height. What's our y final? Right? We know where it starts above the floor. We want to find out where it finishes above the floor at that maximum height. Well, we know from before that our maximum height we'll say at max height, our y final, we don't know. We'll say our final velocity is 0 meters per second, right? Because the ball is stopping and it's about to come back down. So that is an assumption we can make at the maximum height right there. What else is true? Well, we know the initial velocity, that's 6 meters per second, coming off the person's hand. We know the acceleration, that's negative 9.81 meters per second squared. And we don't know the time, but that's okay. We do know the y initial. We know the initial position. That's 2 meters off the floor. We should be able to find our final position. Don't we have an equation like this? V final squared equals V initial squared plus 2 times A times delta y. Well, sometimes we say times G times delta y, but you know what I mean. All right, let's solve for delta y, and then we can solve just for our y final. So I'm going to go V final squared, bring the V initial squared over, so I'll have to subtract that, V initial squared, all that over 2 times our acceleration equals delta y. Well, let's break that delta y apart a little bit, all right? Equals y final minus y initial, right? Isn't that delta y right here? Y final minus y initial. And since we're really just solving for y final, let's take that y initial and just add it to the other side. Can I erase that? No, I can't. It doesn't want to let me erase. That's all right. I'll just, don't want to do that. Well, my erase function is really kind of funky right here. I'm just going to write it again. Sorry. V final, and now I'm writing in green. I'm going crazy. V final squared, that's 0, of course, minus V initial squared over 2 times our acceleration plus y initial, because we brought it over from the other side, right, equals y final. Now, man, I'm really in bad shape right here because I haven't leave myself much space. How about heck, I'll just do that. Does it bother anybody? All right. At least I have more space to write on now. So what is my V final squared? My V final is 0. All right. 0 minus my V initial, that's 6 squared. That's on top. Down at the bottom right there, 2 times negative 9.81, definitely true. Plus my y initial, so that's plus 2 meters equals my y final. And so what do we get? So it's negative 36 on top, I know that for sure. Negative 36 divided by 2 times negative 9.81. All right, and then I'm going to add the 2 meters we started with. So I'm going to say 3.83 meters off the floor. Is that right? 36, 2 times, yeah, that's what I got. And there we go. All right, so that's our maximum height above the floor. Because we set our final velocity right there to be 0, and then just plugged everything else in. All right, that's example 3. Oh man, I promised it was going to be shorter. Well, that was about exactly 10 minutes, so sorry about that. I'm trying to keep it right to 10 minutes. Example 4 will be 10 minutes or less. That's all I can promise you. So see you on the next one.